Good morning, ladies and gentlemen. Cyclists, as vulnerable road users, are to a larger extent exposed to atmospheric conditions, much more so than car drivers. Literature points out that approximately 60% of all cyclists consider weather conditions when they decide to ride a bike or not in a given journey. It also turns out that the daily variability of bicycle traffic is in 80% described and therefore determined by weather conditions. Literature indicates that bicycle traffic intensity can be significantly determined by by weather conditions. Even a slight change in the temperature, atmospheric temperature, could change the number of bicycles in the road. The presentation is based on literature, mainly foreign literature, but I tried to answer the following questions. Which weather factors have a significant impact, statistically significant impact on bicycle traffic volume? And what is this impact in qualitative and quantitative terms? Which factors determine the impact of weather conditions on bicycle volume? And finally, based on own models and models available in the literature, models for bicycle accidents frequency, we wanted to find out how weather conditions could affect the predicted number of collisions involving cyclists. I went to several databases, including the Scopus, and I took 30 papers that I analyzed. You can see in the graph how many texts from various years were present in this set. I wanted to point out that my purpose was not to look at the latest research only, but look in a more overall way, to point out that this issue was already dealt with in the 1970s, that the subject keeps returning, and it is ever present and ever current. Quite a lot of texts originated from Europe, the UK, Norway, and Austria, but I only wanted to include some papers from other parts of the world and other climates, like Australia, even Singapore, or Canada. I'm not going to describe in greater detail all the research. If any of you are interested, I would like to refer you to the presentation, but I wanted to just present the basic conclusions from the literature review that I run. We would like to, the conclusions are to how to could be a guideline on how to run similar questions and how to interpret the results. The factors that are usually considered is air temperature, precipitation, sunshine, cloud cover, humidity, and wind strength. The sequence in which I listed these factors is actually important, because it is air temperature and precipitation that are most important and have the highest impact. The other ones are less important. Many reports indicate that air temperature has a non-linear relation to the intensity of bicycle traffic. As it grows, the intensity also increases, but over a certain value, which is usually at the level of 25, 28, sometimes 30 degrees centigrade, depending on the source. Then the intensity starts decreasing because the weather is too hot for cyclists and they go for a different mode of transport. Now, whether a given weather parameter affects the intensity of bicycle traffic and in what way, obviously that is modified by a number of other factors. In all of these reports, data from weather stations is used. So information is taken about the actual temperature and wind strength. But it's also worth noting that some of the cyclists actually make their decision based on the forecast that they read, often a day earlier. And the forecast could significantly differ from actual conditions, which means that we might fail to capture the relation. Also, the variability of the weather parameter and the length of the analysis period is also important. When you have a very short period of analysis, but also in climate zones where temperature remains unchanged for a period of time, that could show you that the factor is not statistically significant. Weather conditions may be considered qualitatively and quantitatively. If we look at quantitatively, we mainly see that in terms of precipitation, where there's a 0-1 system. Was it raining? Was it not raining? It doesn't matter if it was very intensive for a whole day or was it just a short shower. Usually in those measurements, it's rain or no rain. Also, temperature is often analyzed in categories. Was the temperature from 0 to 10, from 10 to 20, or over 20 degrees Celsius? So it is important to look at the units in which the weather parameter is measured. This is best illustrated here by precipitation, because if we consider precipitation as the millimeters, quantity in millimeters, the same quantity can be typical for a short, very intensive rain, but also for an all-day drizzle. And the effect on cycling can be completely different. When we look at the methods of data analysis, the relation between bicycle traffic intensity and weather conditions, these are usually present in the format of regression models. These are built based on daily or hourly data about bicycle traffic. And generally speaking, these dependencies and relations for daily are characterized by higher determination coefficient R squared than the hourly. But those based on daily do not allow us to account for weather changes over the day. Weather can change during the day. It's also pointed out that since most bicycle traffic takes place during the day, perhaps it's more adequate to take into analysis average temperature not for 24 hours, but for daytime only, and also consider rainfall precipitation only for daytime. As for the methods of data collection, there are two main groups of methods. Mainly this is empirical research, where the data about bicycle traffic usually is collected from automatic stations, automatic counties. The second is survey research, and here surveys can be further subdivided into two groups. One is preference survey, where the respondents can evaluate weather conditions and various parameters such as air temperature and precipitation, also compared to other factors that can affect their decision, such as infrastructure type, continuity of the infrastructure, and the presence of bicycle parking sites. They can, for instance, be surveyed to assess them from more or less important, where, for instance, you can have a scale of 0 to 5 or -5 to +5, where 0 is neutral. -5 is negative, +5 is very positive. This sort of research does not allow one to test the intensity based on atmospheric conditions, but it could be an indication for the administration of bicycle roads as to what should we look at when we want to encourage people to take a bike. A second group is research based on trips actually made. So people are asked in a survey what sort of trip they took, what was the destination, what was the goal, how long was it, and at what time was it taken. This is then compared with the data from weather stations. The effect on the effects are always dependent on the time, various factors such as the probability of taking the bike depending on the purpose of the travel, for instance. So since there are so many factors that are added, it's very difficult to easily compare those surveys and this research. Now, on average, we can say that there is significant impact of weather on cycling. I wanted to use the available research to more or less assess how weather conditions can affect the intensity of bicycle traffic, hence cyclists' decisions. Based on available literature data, I defined accident models. I presented them 2 years ago during Gambit, but because of the certain delays and because we are short of time, I will not describe why we have 3 different models. However, we need to know that in all 3 models, we're looking at average intensity of bicycle traffic. If we have a situation that in winter time the increase is by 10%, from the graph we can point out that the predicted number of accidents will increase by 4 to 5%. These sort of considerations short term I did using crash models available in literature. Here, based on the model from 2012, we can find out that the increase of air temperature by 1 degree centigrade increases in cycle traffic intensity by 2.6%. Increase by 5 degrees is 13% increase, and that in turn increases the risk of cyclists participated accident by 9%. By 5% a collision of a cyclist with a motor vehicle. And this is how we should read all the other data in the table. The increase of air temperature usually increases the intensity of bicycle traffic, therefore it increases the risk of accidents. If it's raining or if there is stronger wind, then the intensity of bicycle traffic is reduced, and therefore the predicted number of incidents per day is changed accordingly. The biggest impact is seen from temperature and precipitation. Wind and number of sunny hours in the day is less important. Summing up, weather parameters, especially air temperature and precipitation, but also the number of sunny hours, cloud cover, humidity and wind strength, they all do have statistically significant impact on bicycle use, which indicates that weather should be considered in all analysis where the bicycle traffic data is used. When we run empirical tests for bicycle traffic on other days and we need to compare intensity, we have to keep in mind that on a given day the temperature could be higher by a few degrees centigrade, maybe there was stronger wind, and that would affect the intensity of bicycle traffic. So direct comparison of those results might not give us the correct results. We also need to remember that when we estimate the increase of mean daily bicycle traffic intensity from counters, and we see that there is an increase by 5%, then we should be aware that the increase by 5% does not necessarily result from the fact that cycling became more popular than the previous year, or the bicycle became a more attractive vehicle than a car, but because we had a warmer autumn, drier winter, and cycling, there were better conditions for cycling. This whole presentation was based on the relation between weather and intensity of traffic, but there is also research where you can research weather conditions versus average bicycle speeds. We see, especially in Kraków, very often, yes, last sentence, we observe more intensity of traffic of electrically powered scooters, since these users are exposed to the elements in the same way as cyclists, and they often use the same infrastructure at similar speeds. So these sort of tests could also be done with relation to these road users. Thank you very much for your attention.